Today is the first lecture of our subjects Industrial Stoichiometry 2. Should we start now?
वेट कर लेते हैं स्टूडेंट्स ज्वाइन कर रहे हैं
ओके आप लोगों को आवाज़ सही आ रही है मेरी? हम लोग इसको स्टार्ट करते हैं. Okay class, my name is Saira Bano and I'm going to teach you Industrial Stoichiometry 2. आप लोगों को स्टाइको 1 कुछ याद है? आप लोगों ने फर्स्ट सेमेस्टर के अंदर पढ़ी थी, कुछ याद है? थोड़ा बहुत ज़हन के अंदर हो. हम लोगों ने पहले कुछ एक बड़ा मेजर सब्जेक्ट था जो हमने आते साथ हमने स्टार्ट किया था.
यस मैम
ओके अच्छा क्लास, आपका आप लोगों को अब तक तो आइडिया हो गया होगा. दिस इज़ योर थर्ड सेमेस्टर. आप लोगों ने एक साल यहाँ पे गुजार लिया है और सब्जेक्ट्स के बारे में आपको कुछ ना कुछ नो हाउ हो चुकी है. विच वन इज़ योर मेजर सब्जेक्ट? कौन से आपके ऐसे सब्जेक्ट्स हैं जो आपको स्टार्ट में अगर आप पढ़ रहे हैं एंड देन वो आपको फाइनल ईयर तक आपके साथ चलेंगे. एंड इंडस्ट्रियल स्ट्राइको इज़ वन ऑफ दैम. ये सब्जेक्ट अगर आपने फर्स्ट सेमेस्टर में स्टार्ट किया था, आप देख रहे हैं कि ये थर्ड सेमेस्टर के अंदर भी आ रही है आपके पास. और थर्ड सेमेस्टर के साथ साथ ये आपको आगे भी डिफरेंट, जैसे जैसे आप आगे जाएंगे, इवन अभी आप लोग नेक्स्ट जो पढ़ेंगे अपना, साथ ही आप लोग थर्मोडायनेमिक्स आप लोग पढ़ रहे होंगे, थर्मो 1. यस
Excuse me, ma'am.
यस.
We are six foreigner here. So may you speak English, please?
Okay. How many foreigners are here?
We are six, ma'am.
6. Okay. Okay. Okay, class. We are going to start our subjects Industrial Stoichiometry 2, as you have already completed your Stoicho 1 in the first semester. And now you must be familiar with the importance of this subject, as you will find little bit of Stoicho 1 in different subjects, like you are going to study thermodynamics 1 in this semester. And you will see that there are many topics, there are many things which are familiar in both the subjects. Like you have studied already some basic concepts which I will revise in these lectures. In the first week, we will revise a little bit of Stoichiometry 1, and then in the from the next week, inshallah, we will focus on our major topics. So coming to the okay, one more thing. This subject is very important for you people. आप लोगों ने okay, still students waiting. 1 second, class. Okay. When in the coming semesters you are going to study mass transfer, heat transfer, and then there will be heat and mass transfer simultaneously occurring in any unit or in any industry, and you will need stoichiometry there. Then in your final year, you will be doing your final year projects, and the first part of that, the major part, there are two parts of final year project. First one is material and energy balance, and second one is the designing. So when energy and material balance, as far as these are concerned, you have to study industrial stoichiometry. So you have to study it, you have to completely understand it. If you don't understand it, there will be no cramming, there will be no reta system or something, because the paper will be also be kind of unseen bhi ho sakta hai, and there can be some changes in the question, and you have to do it yourself all in the limited time. So I would suggest you guys, आप लोग साथ साथ पढ़ रहे हैं. You must follow whatever I am telling you, or Dr. Saima will be teaching along with me. So if you find any difficulty, you can ask me in the same lecture or in the next lecture. Whatever I will assign you, I hope you guys will do it in time and discuss with me in the same week. So it will be better for you. It will be inconvenient for me as well. It wouldn't be good if I'm teaching you something in first week and then you are coming to me in the eighth week and you are telling me just I don't know exactly how much material balance you have studied there. So if the class representative or any other student would just tell me the major books you followed and the so I will next further. So any student will tell me आप लोगों ने कौन सी major book follow की थी in Styco 1 if you remember. Class
Basic
जी
Principles and Calculations in Chemical Engineering by Hamel Blow.
8th edition.
Yes.
Okay, and did you follow Hujan and Watson as well?
Yes, ma'am.
Okay, so basically these two books go side by side, and even here we will follow these two books majorly, but there will be some other books as well that will be shown in the next slide. So I think in Hujan and Watson, but I think आप लोगों को भी याद नहीं होगा chapter 7 and that do you remember something कौन से chapters आपने follow किए थे in Hujan and Watson? It would be difficult, I think. अच्छा, who was your teacher? Okay, just tell me one thing. I will discuss with him.
Amir Abbas.
Amir Abbas. Okay, fine. Thank you. Okay, okay, I'll discuss with him. And then, okay, class, I think in this trichometry one, as far as I remember, there were basically material and energy balance you started, and then there were basic concepts of them. But in detail, all the topics will be discussed in trichometry 2. But I will give you some practice questions. I will practice with you. मैं भी आपके साथ ये करूँगी साथ साथ, and we will see कि आपको कितना पिछला revise हो गया, and then we will move to the further in material balance. Because I believe if you don't remember the previous things, you cannot move further. आप लोगों को पिछला concept clear होगा, then you will move further. So material balance without reaction, material balance with reaction, then we will focus. ये हमारा Styco 1 में से कुछ चीज़ें आएंगी, and then we will move to the Styco 2, which includes steady state material balance involving involving recycle without chemical reaction, recycle with chemical reaction, then there will be bypass and purge streams. All these calculations, they will be for with and without bypass and purge में भी हम यही चीजें देखेंगे. Then material balance will be concluded and we will move to the energy balance calculations. For energy balance calculations for reacting systems. But obviously for reacting systems, before going to the reacting system, we have to see somewhat about the non-reacting systems, जो आपका Stoichio 1 का part था. So we will touch also non-reacting systems, and then we will practice all the questions, all the problems related to it. And finally, there is combined material and energy balances on reacting and non-reacting systems involving multiple units and reactions. ये आपके पास एक आप कह लें कि upgraded form होगी. It will involve both material balance and energy balance. It will help you in your final year project, because I know final year में in your final year project you will need this material and energy balance, as I told you earlier. So to understand all the units, to understand all the functioning of every units, to understand all the reactions, then you need material balance, then you will go to energy balance. Our parallel में ये दोनों चीजें साथ चलेंगी, so you need combined material and energy balance. That will be our last part, inshallah. So here again, the books we will be using, first one is again Himmelblau. It's 8th edition, Basic Principles and Calculations in Chemical Engineering, edition 8. Then there will be Hujan and Watson. It's part 1, Material and Energy Balance. Then Felder and Rousseau, and then finally Reclatus book. So I will be taking some problems from different books and I will share with you. I will assign you and you have to do this work side by side. Okay, so our grading strategy would be midterm 30%, final term would be 40%. There will be 2 quizzes and class attendance and assignment. These all will be sessional 30%. Class assessment attendance doesn't mean your physical presence. आपने साथ साथ सारा solve करना होगा problems को. You have to understand. You will be participating in discussion. You will be asking, and that will be your class attendance actually. Okay, now I will talk about the basic term stoichiometry. Stoichiometry क्या है? Stoichio means elements and metry means to measure. So actually stoichiometry is basically the measurement. It is considered to be the mathematical part of chemistry. And if we talk about some definition, then it is the study of quantitative relationships between the amounts of reactants used and the amounts of products formed by a chemical reactions. Actually, this one basically focuses on the reacting systems, but we know that when you discussed material balances without reaction on different units, whether it is a distillation column or it is an evaporator or some mixer even, then some streams are adding, and we are adding some streams, they are mixing together, and then finally some stream is leaving. So input and output, हम इसके ऊपर whether there is a reaction involved or not, we will be focusing on the input and output systems. So stoichiometry क्या होगी? ये आपका input and output इसको लेके चल रहा होगा साथ में, and it basically based on the law of conservation of mass. What does law of conservation of mass states? Any student? Law of conservation of mass क्या कहता है?
Mass can create not destroyed, but it can from one to another.
Okay, anyone else? Some in some other terms, some other words में अगर कुछ कहें.
The mass of reactants is equal to the mass of product.
Okay, yes, always equal. Input is always equal to output, ठीक है? And depending upon के accumulation term is 0 there. आपके पास पूरा जो law of conservation of mass क्या कहता है? Input is equal to output, depending upon कि आपके पास accumulation term जो है that is 0 there. ये हम आगे डिटेल में आगे साथ में इसमें देखेंगे. कुछ बेसिक टर्म्स हैं जो which you have already gone through in Stoichiometry-I. So I would hear from you people, if you could answer me one by one. Any volunteer? First one is dimensions. I will give you a minute. आप लोग इसके ऊपर सोचें.
Excuse me, ma'am. Ma'am, dimensions are used to express units.
अच्छा. Okay. Anyone else?
Measurable extent of a unit.
These are some means of measurement. Some concepts हैं, some कुछ चीज़ें हैं ये जो कि खुद measurement को indicate कर रही होंगी, ठीक है? And some basic concepts हैं, and any example of dimension, if you would give me. Then we would move to units.
Length, mass, time,
Mass, time,
length,
and
temperature.
length, temperature, mass, time, etc. ये सारी चीज़ें आपके पास dimensions में आती हैं. And then units. Units आपके पास क्या होंगे? These are actually the means of expressing all the dimensions. For example, अगर हम length की बात करें तो इसके कोई units आप बताएंगे मुझे?
Meter.
Meter, centimeter, feet.
In SI system, it would be meter, or then centimeter and kilometers can be. And in American engineering में अगर हम देखें तो उसमें क्या सिस्टम होंगे आपके पास?
Foot,
इसके
inch, feet,
exactly. Actually foot होता है इसमें, and then inches वगैरह में ये आ जाता है. Second one is mass. Mass के anybody would tell me what is the unit of mass, and then it's SI unit and American engineering unit as well.
Kilogram.
Kilogram in
Gram,
pound.
kilogram, and American unit LB.
LB. Okay. All right. And then we had temperature. Temperature के बारे में.
Celsius,
Celsius.
and
Degree
Kelvin.
Celsius and Kelvin, and American engineering में.
Fahrenheit.
Fahrenheit.
और another one.
Rankine.
Rankine में भी आते हैं.
Heating.
Okay, class, you have already done these units and dimensions in your Stoichiometry-I, and you must know some fundamental and derived units and as well. Is it so? So कुछ derived चीज़ों के बारे में आपको अगर पता हो.
मैम pound force होता है एक अमेरिकन में.
Pound force, that is for force actually. You're right. Derived कुछ dimensions, for example, अगर हम fundamental, if we talk about the fundamental dimensions and units, these are actually independent. These are they can be measured independently, and they are sufficient to describe essential quantities. But when we talk about the derived ones, they can be described with the help of the fundamental ones, like length, mass, time, temperature, etc. They all are fundamental dimensions and units. And then if we talk about the derived ones, if you could give me some example other than force, as someone said here. So any other example of derived?
Velocity.
Velocity, yes.
Acceleration.
Speed.
Yes.
Density.
Pressure, yes. Then energy आएगी, density है, इस तरह से multiple values इसके अंदर आएंगी, ठीक है. So next comes mole. What is mole? Okay, what is mole?
Actually, ma'am, mole is a base quantity and is used to measure the amount of a substance.
Exactly, and there are two different. It can be expressed in two ways. First one is gram mole, and the second one is pound mole. Depending upon the system you are using, if it is SI system, then it will be gram mole, and then in American engineering, it will be pound mole. Okay. Okay, then mole का जो formula basic है that you know very well, it is mass in grams or pounds divided by molecular weight. And this molecular weight can be in grams per gram mole or pounds per pound mole,
Molar
depending कि
mass.
आप एग्जैक्टली आप कौन सा यूनिट इसके अंदर यूज़ कर रहे हैं उसके अकॉर्डिंगली आप इसमें वैल्यूज़ यूज़ करेंगे सो यूनिट्स एंड दीज यूनिट्स आर वेरी इंपॉर्टेंट इफ़ यू हैव if you remember Stoichio 1 then you know it very well. Okay, next term is density.
Mass per unit volume.
Exactly, mass per unit volume, and the units can be what will be its units? Anyone?
Kilogram per meter
Kilogram
cube.
per meter square.
Meter square?
Meter cube.
Cube, yes.
Cube. Cube.
जी बिल्कुल. And then if you talk about in the American engineering, it will be pound mass divided by cubic feet में ही आएगा. ठीक है. So next term is specific volume.
Reciprocal of density.
Exactly. Inverse of
Reciprocal of
or
density.
reciprocal of density आपके पास आएगा, and then आप formula will be in volume divided by mass. Okay. So next is flow rate.
Mass per unit time or mole per unit time.
Exactly. It actually represents the rate at which a material is transported through a pipe, and it can be mass flow rate, it can be molar flow rate, or it can be volumetric flow rate. So depending upon the type, आपके पास formula जो होगा that will be changed in mass flow rate, mass per unit time. Molar flow rate की अगर हम बात करेंगे, then it will be number of moles per unit time, and then volumetric flow rate में volume per unit time. Okay. Okay, so next is the mass fraction and mole fraction. If you have some mixture of components, let's say two or more than two or more than two components, then you will be using these terms mass fraction and mole fraction. क्या होता है ये? What is this?
Ma'am, ratio of a mass of an element to the total mass of the compound.
Of the compound or the
Mixture कह
mixture?
लें.
Mixture, exactly. Mass fraction, अच्छा, its value is greater than 1 or less than 1.
Less than 1.
Equal or less than
Less
one.
than.
Less than.
Equal or less than 1. Okay, and what about mole fraction? What is mole fraction?
Ratio of moles of one element to the ratio of moles of compound.
Mole mixture. Mole mixture के अगर हम okay, compound mixture. And then what about its value? It will be above 1, more than 1 or less than 1?
Less than 1.
It will be less than 1. Remember one thing, whenever you are talking about the fractions, it will always be less than 1. Okay, mostly. Because if it will be 1, that will be a pure component. And if we want to convert it to some percentage, the fraction will be multiplied by 100, and mass fraction will be converted to mass percentage, and mole fraction will be converted to mole percentage. So you have to multiply by 100 to get mass percentage and mole percentage. So next comes the limiting and excess reactant. What is limiting reactant?
Reactant that is fully
Which
consumed
causes the
during the
reaction
chemical
to
use.
stop.
which causes the reaction to stop. Another one, आप बेटे आप कुछ कह रहे थे?
Which consume first?
Ma'am, reactant that is fully consumed during a chemical reaction.
That is fully consumed. To some extent, this definition is okay, but if we talk about 100%, if the degree of completion of reaction is 100%, अगर आप ये कहते हैं कि all of the reactant यानी कि हमारे पास जो conversion हो रही है ये 100% reaction achieve हो गया है, in that case it will be true. But if the overall conversion of reaction is not 100%, we will discuss it in our upcoming lectures, then this cannot be true because all of the limiting reactant will not be consumed in the reaction, okay? Depending upon the conversion, if it is 100% consumed, limiting reactant can be consumed 100%, it will stop the further reaction, yes, it is the limiting reactant. So आपके पास जो major progress of reaction है, it depends upon the limiting reactant, it basically controls your reaction. हम कुछ इसमें प्रैक्टिस प्रॉब्लम्स करेंगे एंड आप देखेंगे कि लिमिटिंग रिएक्टेंट 100% कंज्यूम होता है या नहीं होता है, ठीक है? तो दोनों केसेस हो सकते हैं यहाँ पे. And then excess reactant which is present in excess of that required for the reaction. तो आपने I hope कि आपने कुछ problems किए होंगे where you must have calculated, you must have guessed the limiting reactant, excess reactant and then percentage excess as well. So a little bit revision of that will be done in this week and then we will move to the further problems. Okay, next is degree of completion. क्या होता है ये? Degree of completion, does every reaction go to 100% completion? Is it so? हर reaction जो है वो complete हो जाता है? All of the reactant will be converted to the product? No. Why?
No, ma'am.
Why? What can be the
there are some reactions
factors?
which are reactions.
Which are? Sorry, if you would repeat it.
Some reactions are reversible reactions, so
Exactly. Some reactions are reversible, so they cannot be completed 100%. Anyone else?
Either we have to remove the product after completion of reaction, and also we have to add what do you call it, a catalyst.
Yes, that is to overcome the reversibility. So there can be some equilibrium where reactants are being converted to products and products will be converted back to reactants. So we have to use some methods to disturb this equilibrium, to disturb this reversibility, and then the reaction may be 100% completed. So the equilibrium and reversibility, it can be first reason. Another reason can be insufficient time given for the completion of reaction. So if the time of reaction required is around 30 seconds or 1 minute and you are giving it time less than this, the required time, then there will be no 100% completion. So incomplete conversion है, partial conversion हो रही होगी और reactants की, and then comes the term of conversion. These two are related to each other. When we talk about the degree of completion, if you remember its formula, that means the conversion, we are mainly focusing on the limiting reactant. So how much limiting reactant has been converted to the product, that will indicate the degree of completion of reaction. And then comes the conversion term. Conversion means any reactant. It can be the excess reactant or the limiting reactant, any reactant, how much its amount has been converted to product. So the amount of reactant converted divided by total amount of the reactant provided, that will give you the conversion. And usually it is expressed in percentage, so it will be multiplied by 100 to get the percentage value. Okay, so I will discuss with you in detail in next lectures because we will be practicing some problems. So I would expect from all of you to bring your calculators along with you, and your notebook, your calculators आपके पास होना चाहिए. I will share with you some problem or question, and you will be solving it right there. And then I'll ask you the answers. आप लोगों ने आपके पास क्या इसका आ रहा है? And if you find any difficulty, you will ask me there and then, so that it may be solved right there. Okay, class? So most importantly, your calculators. ठीक है? This is not some theoretical subjects where slides would be enough and you will finish your work later on. ऐसा नहीं होगा. You have to do it along with me. आप लोगों ने जैसे जैसे lecture चल रहा होगा, आप लोगों ने साथ साथ problems solve करने होंगे. आपके calculators, आपकी notebooks आपने अपने पास रखना है, ठीक है? This will be your what I would say. आप लोगों के लिए सबसे ज़्यादा फायदा में beneficial for you guys. Okay? ठीक है class?
Yes, ma'am.
Yes, ma'am.
Okay. So for the until the next lecture, I would ask you guys, आप लोग अपने just go through your industrial stoichiometry-I notes, basic things only. All of these things you have already covered in your stoichiometry-I. I would expect next time when you are in the lecture, you have gone through all your notes. Just go through them once. It will take hardly 1 hour or 2 hours, and then you will be able to move further. फिर हम लोग जब मटेरियल बैलेंस के ऊपर जाएंगे या किसी भी चीज़ के ऊपर जाएंगे, तो ये आप लोग इसके साथ ऑलरेडी फेमिलियर होंगे. इट वोंट बी अ स्ट्रेंजर थिंग फॉर यू गाइस. ठीक है? तो आप लोग इसको पढ़ के आइएगा, एक दफ़ा गो थ्रू करें सारे का सारा, एंड देन इफ़ यू फाइंड एनी डिफ़िकल्टी तो फिर हम इसको आपके साथ रिजॉल्व करेंगे. ठीक है? एंड नेक्स्ट टाइम इंशाल्लाह वी विल स्टार्ट प्रॉपर्ली. आपके जो होंगे प्रॉब्लम्स होंगे वो हम सॉल्व करना स्टार्ट कर देंगे इसके अंदर. ठीक है? सो एनीथिंग यू वांट टू आस्क फ्रॉम मी, यू आर वेलकम. इफ यू फाइंड एनी क्यूरी, कोई भी चीज़ अगर आप पूछना चाहें. Okay. So who is the class representative of both sections, section A and section B?
Yes, ma'am.
Section A, first I would like to hear from you. Section A के CR.
आज क्लास अटेंड नहीं कर रहे.
अच्छा आज नहीं है. Okay. And section B?
Yes, ma'am.
Okay. CH58. Better may I know your name?
Yes.
सॉरी आपकी, चलिए मैं आपकी लिस्ट में से देख लूँगी. रोल नंबर मुझे पता लग गया. I will check from your list. Okay. आई होप सो कि नेक्स्ट वीक से क्लासेस जो होंगी ये ऑनलाइन ना हो. देन आई वाज टोल्ड आई वुड बी टेकिंग सेक्शन बी एंड मैन साइमा विल बी टीचिंग सेक्शन ए, बट लेट्स सी, होप फॉर द बेस्ट. अंटिल अभी जो है फ़िलहाल तो ऑनलाइन है. देन आई एम टेकिंग इट. सो आई विल डिस्कस विद तरह से आगे लेक्चर कौन देगा. ठीक है? बट इट विल नॉट बी अ प्रॉब्लम फॉर यू पीपल. इंशाल्लाह एवरीथिंग विल बी स्मूथ. ठीक है?
Yes, ma'am.
चलें ठीक है. ओके
Thank you.
क्लास, इंशाल्लाह नेक्स्ट लेक्चर में विल मीट. आप लोग अपने, मेरी रिक्वेस्ट ही होगी, जस्ट ब्रिंग योर कैलकुलेटर्स प्लीज़. ठीक है? ताकि किसी भी किस्म के हम वो टाइम वेस्ट किए बगैर हम अपना काम जो है वो प्रॉपरली स्टार्ट कर सकें. ठीक है? ओके, सी यू सून इंशाल्लाह. नेक्स्ट लेक्चर में आपसे बात होती है. टेक केयर.
Allah.
अल्लाह.